So last class we had done till distance and displacement. Once we had we completed distance and displacement, now we are supposed to do speed, velocity, and then uniform speed, uniform velocity. Actually, we are going to do like motion, the displacement we finished, distance also we finished. So now we are going to do is what? Let's see. We'll see the things we are going to do today. So if you'll see the lecture analysis today, that is what uniform motion and non-uniform motion, speed and velocity, and then average speed, average velocity, and then archive questions like we can see NTSE and all those questions we'll see here. Fine, NCRT questions. First we'll see the basic questions and then we'll see tough numericals. So uniform speed, uniform motion and non-uniform motion, and speed and velocity. So speed and velocity, average speed and average velocity, these topics are really important. It plays an important role in motion chapter. So let's see, the first thing is what? Uniform motion and non-uniform motion. Suppose a truck is there, right? If you'll see a truck is running in a trap is there, like it is running in a road with a speed of 60 km per hour. If it is 60 km per hour, it is running with a speed of 60 km per hour, then we can say 60 km per hour for 3 hours it is running. Then directly we can say 180 km it will travel in 3 hours. Because it is going in 1 kilometer 60 km, in 1 hour 60 km, another hour 60 km, another hour 60 km. So 60 plus 60 plus 60 to 180 hour we can say. Now we can say like non-uniform motion. Suppose if you are going from here to, let's take Sholinganallur to Adayar, you are going, and that too it will go by 11 o'clock. Let's take like 10 o'clock you are going. So around for 10 kilometers distance is there, 10 to 12 kilometers. So it will take more than 2 hours, more than one hour. If you are going by car, then of course it will take 1 hour. The problem is what here? Whenever the distance will be like more rush will be there. Many signals are there. In highways there will be no signal, so it will be easy to travel there. So we can say suddenly your speed will go down and then it will come up. Again, like your motion is going to decrease, going to be 0. You may rest for 5 minutes, 6 minutes. Again, then you will start your motion. So that type of speed, that type of motion is known as non-uniform motion. It means what? The graph, if you will see in uniform motion, it should be, suppose this is the distance and this is the time graph, if you will see. Then for uniform motion, the graph should be like this. Of course, it should be like this. But non-uniform, this is time and distance, we can say. And then if you see the graph here for non-uniform, then it can be like this. Any absurd kind of graph that you can draw here. That is what I wrote here. Uniform motion is what? Motion in which the body travels equal distances in equal interval of time. Non-uniform. Uniform, you can take, suppose any school is there that has a uniform. Let's take black shirt, white, black pant, white shirt. Then we can say everyone is wearing the same thing. That is what uniform motion. In college and all, generally nobody is having. There is no college, like generally colleges are not having uniform. So there, somebody is wearing t-shirt, somebody is wearing shirt, somebody is wearing green color shirt, somebody is wearing purple color shirt. So that is non-uniform. Uniform means equal distance, equal. So there also what? Uniform, if you will consider like in school and all, like school, then we can say what? Uniform is equal. Everyone is white shirt, black pant, white shirt, black pant. But non-uniform is what? Like it can be any color. Right? So that is what? Uniform motion. So here we can say uniform motion, equal distance and equal distances, motion in which the body travels equal distances in equal interval of time. Here is what? Non-uniform motion in which a body travels in unequal distances in equal interval of time. So we can say, suppose a particle is running starting from here 0, then in 1 hour it covers 50, another hour 50, another hour 50. Here is what? First hour 50 kilometer, second hour is 100 kilometer, third hour is what? 30 kilometers. So that is what? Non-uniform. Hope so you guys understood. Uniform motion means what? Equal distance, equal interval of time. Non-uniform means what? Unequal distance in equal interval of time. Okay, so graph if you are going to see, then we can say that what? Let's take suppose 1, 2, 3 second in time, and then it is in meter. 100, 200, 100, 200 and 300. So we can say now the graph is going to be like this, and this is again see one is increasing and here it is increasing anyway. Now if you will see here, this is increasing, time is increasing, but distance is not increasing. So these types of motion is what non-uniform motion. Fine. Now we are going to see speed. Speed is what? If you go by a book's definition, then it is a rate of distance covered in a unit time. Leave that. If you see speedometer in a car or something, there will be a speedometer. So there we measures what speed. Speed is what? There will be a needle will be there, and then it goes 60. Like suppose 90, it will go like this. 10, then it will be like this. So that is what measuring speed. Now somebody will say 60 km per hour, 80 km per hour. Obviously 60 km per hour is greater than what? 80 km per hour. Okay, speed, if you see more, then we can say that what? Speed is without direction. Speed is what? Without direction. And it is denoted by what? Without direction means, in the last class we learned that is a scalar quantity, right? Same thing if you'll see its unit is what? Distance by time. Speed is what? Distance by time. So meter per second, we can say distance is unit is what? Meter, and then by time unit is what? Second, or we can say kilometer per hour, or we can like long distance and long time it takes, then kilometer per hour, it will be easy for us. And then meter per second for small distance, small time. It is denoted by capital V, and then it is a scalar quantity. Now there is a conversion, kilometer per hour to meter per second. 1 kilometer is how many meters? 1000 meters. That is what I know. 1000 meters. And then what? R, if you will see, is 60. 60 minute and 60 second. So 60 minute and 60 second. So 0 to 2 zeros cancel out. Then 36 by 10. 10 by 36. That is going to be 2 times 18. So 5 by 18 is equal meter per second. So we can say 1 kilometer per hour is equal to 5 by 18 meter per second. So by that way, if you want to convert kilometer per hour into meter per second, then you can just multiply 5 by 18, you will get answer. Okay, so till here hope so it is clear. So speed is measured by what? Speedometer. Now velocity. Velocity, if you see, it is the rate of displacement covered in a unit time. In a unit time, denoted by again what? V. SI unit is what? Kilometer per hour. Same. But is the vector quantity. Why? Displacement is a vector quantity. Now velocity will change when the displacement will change, and what? When the speed will change. Now suppose if you are going suppose like this, suddenly a turn came, then you came here like this. So your speed increase, here decreased, and then so whenever the magnitude of the speed changes, that is also velocity. We can say there will be change in direction. It means ultimately you are decreasing your speed, there will be change in direction. So that we can say. And then second thing, we can say whenever the direction changes, that is what? Velocity. So it is the rate of displacement covered in a unit time, denoted by capital V. SI is kilometer per hour or meter per second. And then we can say again it's a vector quantity, and formula we can say what? Meter displacement by time. Okay, let's see one numerical. An object travels 60 meter east and then 80 meter in north in 20 seconds. Calculate the speed and velocity. Okay, so east, right? 60 kilometer, and then what? 80 kilometer in what? 80 meter in what? What is that? North. Then calculate the speed and velocity. So speed, if you see, total distance by total time. What is the total distance here? Total distance is going to be 60 meter plus 80 meter, right? So we can say now 140 meter. Okay, time is given, that is 20 seconds. So speed is going to be is what? Total distance by total time taken. So total distance is how much? 140 by what? 20. So 7 times. So 7 meter per second is the speed. Fine. So speed is easy. Total distance by total time. Even velocity, if you'll find, then we should find the velocity, then we should find the displacement. Okay. So displacement, we can say now here is going to be like this. This will be the displacement, right? So 80, 60. So you like this is A, this is B, this is C. So BC, if you want to find, then BA is for Pythagoras theorem, you'll have to apply. So ultimately 80 square plus what? 60 square. So we can say 6400 plus what? 3600 is equal to, it means 9000. So 30, no, how much? 9000. Okay, whatever. Root under of that, right? So now we can say that is the velocity we'll get. Okay, velocity is 900. Root under 9000. 30 is not there, correct? 300 is also not correct. Will be more zeros. And then what, by 20? You solve it, you'll get an answer from that. I'm not going to solve. I'm lazy little to solve calculations. Fine. So that you guys can solve. Just find velocity. You have to find displacement. Displacement you guys can find. Last class also we discuss how to find displacement. Fine. So that you guys do by yourself. Let's see now average speed and average velocity. Most important topic in this. Some numericals are really good in this topic. Now what average speed and average velocity? So total distance covered by an object by total time. Total distance by what? Total time. So we can say, suppose if you are going from here to like 500 kilometers you are going, and it takes like 10 hours or 15 hours to cover. So we can say total distance 500 kilometer by total time it takes. That is what average speed. So total distance by total time is what average speed. Remember again, total distance by total time is what average speed. For average velocity, so net velocity by what? The net displacement, sorry, displacement by total displacement by total time taken is what average velocity. Or we can say initial velocity plus final velocity by 2 is also what? Average velocity. So that we are going to see one numerical. Into numericals we'll see directly a tough numerical. Okay, here also anyway average speed or average velocity, it doesn't matter. Average speed is what? Speed, no, again it is a scalar quantity, right? And what is the denoted by what? Small capital S, right? And it is a scalar quantity. Same here, it is a vector quantity. Velocity is right, the vector quantity. Unit is what? Meter per second or kilometer per hour. And then we can say what is the vector quantity denoted by what? Capital V. Okay, fine. So now let's see one numerical. Suppose if you will do one numerical, suppose you are going from home to your school, with a speed of, let's take 40 kilometer per hour, and you are coming back with 30 kilometer per hour. So now they're asking an object, anyone. An object is running in a straight path with a speed of what? Like from, let's take Rahul is going to school, from home to school with a speed of 40 km per hour, and he is returning back with a speed of 30 km per hour. Then find his average speed, average velocity. Then find average speed and average velocity. So this, if you want to find, then let's see average speed. How we'll find average speed? Average speed, if you want to find, then total distance by total time. Fine. What is total distance? We don't know. What is total time? Again, we don't know. And we want to find what? Average speed. So let's see for these types of questions how you are supposed to tackle and how you should think. So we can say one thing here, the distance is going to remain constant. Why? Because when you will go from home to school, suppose here is a home, here is a school. So the distance, suppose this is the distance. When you are coming back also, the distance is, until you are not taking the another path. So we can say that when you are going, if you are going, then what? Same distance. If you are coming back, same distance. So ultimately, if you are considering the distance is what? S. So coming back also is what? X. So we can say now is what? For both it is what? S1. Let's take X. So we can say total distance is going to be, distance is what? XX. So total distance is going to be what? 2x. Okay, let's take now, when you are going, the speed is different. When you are coming back, your speed is different, right? When you go by 8 o'clock, you will go, then you can go with more speed, 40 km. When you are coming back, then of course your speed is going to decrease. Why? Because there will be a rush. All school buses will come in the road. So your speed is what? Less now, 30 km per hour, and you are coming with the same path. So we can say, let's find now time t1 when you are going to school. So that thing is going to be, what is that? Time is equal to what? Distance by velocity. So 40. T2 is going to be x by 30. So total distance, total time, we'll find average speed. So average speed is going to be total distance. Total distance is what? 2x. Total time is what? X by 40 plus what? X by 30. Now if you will solve it, if you will take common x, then we can say 2x by 1 by 40 plus 1 by 30, and then x I took common, x cancel out. Then if you solve it, then you can solve as like what? 2 by 1 by 30, 40. So 1 directly 120. You take LCM. 120 we took what? LCM, and then we can say here, okay, 120 is the LCM. Then here first is what? 40. So 30 times, 3 times, and 40. So 4 times. 30. So 4 times. So now your average speed is going to be what? Now we can say 2 by 7 by what? 120. So that is going to what? Be up. So correct one, no? 3, 4. 2 into 120 by 7. Okay, so now this is going to be what? 1 time and 5. So it is going to be 42 point something. Let's what is that? No, sorry. His average speed is going to be how much? 1 time. So it is going to be 5 and 9 time, no? 49, 50. So 9 time. 38 point something will come. How much? It is coming 5, then 91, and then 38.1 kilometer. Let's take distance we consider kilometer per hour. So 38.1 kilometer per hour. What will be the displacement? Displacement is going to be 0. You are going home. You are going from home to school and coming back to what again? School. So like coming back to home. So you can say displacement is 0. So net velocity is 0. Like velocity, average velocity, V average is equal to what? 0. Because displacement is what here? Displacement itself is what? 0. Fine. Till here we will see today. So we next class we are going to do acceleration part, means the cause of we will not see the cause, we'll see later, but we'll see acceleration next class. Fine. So we learned uniform, non-uniform, and then we learned what? We learned about average speed, average velocity, about speed and velocity. That thing 1 to numericals we did. That's it for today's class.